let us understand what exactly predictive analysis is. So what is predictive analysis? Predictive analytics or analysis encompasses a variety of statistical techniques from data mining, predictive modeling, and machine learning that actually analyze the current and historical facts to make predictions about future or otherwise unknown events. So this is the basic definition from Wikipedia. So we basically use the previously collected data to predict an outcome or an event. So typically, historical data is used to build a mathematical model. In our case, we can call it a classifier or a predictive model or a regressor, which actually captures the important trends. And then the current data is used on that model to predict what will happen next or to suggest actions to take optimal outcomes. So let us take a look at various applications where we can actually use predictive analysis. So we can use predictive analysis for a lot of things. First of all, we have campaign management. So let's say we have a campaign, we have to figure out what kind of audience will be there or what kind of our target audience is. So we can analyze the previous data of our previous campaigns that we might have managed previously. And according to that, we can figure out some suggestions or, the course of action that we have to take. So this is one campaign management that we can do using the predictive analysis. Or for recent examples, let's say an election campaign, a lot of people are gathering a lot of data of previous elections, like how it happened and what are the major factors that led to the winning of some so and so person. So this is how we can use predictive analysis in campaign management. Then there is customer acquisition. So we can analyze the whole business and we can figure out different points to figure out what kind of task or events we can actually produce in order to make our business better, so that we'll be able to make customer acquisition better. And then we have budgeting and forecasting as well. Similarly, taking a look at previous data, we can finalize some budget and forecast few related pointers. For example, we have stock prediction using Python or any other language such as R also. And then we have fraud detection, so we can manage a lot of data. Like for credit card companies, they make use of hundreds and hundreds of users, and they analyze the data to predict or detect the fraudulent transactions in their data. And then there is promotions as well, so we can analyze the target audience. We can follow the trends, like they are following the types of content they're actually going for. And then similarly, you can make promotions according to that. Then there is pricing also, like you can figure out, let's say you have a supermarket, somewhat like what Walmart does. So you have all the pricing and everything. So what you can do is figure out the price of a product after several times based on the recent purchases and also the recent scenario or the previous historical data upon which the price has been distributed accordingly. And you can also plan for the demand as well using the predictive analysis. So these are a few applications that I can think of right now. And these are only a few applications where you can use predictive analysis to predict for example, I'll talk about football, guys. So let's say if you have a favorite player and in the next season you want to see how much price he might go for in certain other clubs. So you can make use of the data at your bay, and depending on the purchases that happen in previous seasons or the windows, you can actually figure out somewhat around what kind of price your favorite player is going to go for. So that is one example I can think of right now. So these are a few applications of predictive analysis. Now let's move on to the next topic of the session, guys, which is steps involved in predictive analysis. So this is a very important concept in this session, guys. So you have to fully understand what kind of steps that goes in while you're doing a predictive analysis. So the first step has to be a data exploration. So what you have to do is gather data, upload it into your program. Then you have to take a look at your data in a perspective which will clear certain things for you. Like you have to figure out what kind of data you're dealing with, what are the columns, what are the features that you have inside your data, what kind of data it is, how many numerical values are there, what kind of data types are there inside your data, is it a CSV file or not, so on. So you have to figure out a lot of things while data exploration. And after that, you can figure out how to clean your data. By cleaning, I mean you have to figure out the redundancies that might hinder your model. So for that, you have to check for null values, you have to check for missing values, and then you have to figure out what kind of columns will be actually better if you put them inside your model, and what are the redundant variables, like what kind of columns that you can actually remove and will not make a difference in your model. So that covers the data cleaning part. And then there is modeling, where you have to model your or you have to select your predictive model, guys. So there are a lot of models that you can go for, but in this session I'm going to use the linear regression model because it's the very simple or the basic one. so that the beginners also will be able to learn it properly. After modeling, you have to check for the evaluation, or you have to check for the accuracy, how your model is actually performing. So let's talk about these steps in a little more detailed way. So we'll talk about data exploration first of all. As I've already told you, data exploration is gathering your data and then taking a look at your data in a perspective that will clear a lot of things. For example, you will be able to see the number of columns, number of rows. You will have a description of all the data types, what kind of variables are there. You will have the mean values, the average values, minimum values, and you can also check for unique values in your columns as well. So this all comes in data exploration. And after this, the second step is data cleaning. And I've already told you guys, data cleaning is basically getting rid of redundancies in your data, which includes the missing values, which may hinder. And you have to make sure that your model is not going to cause overfitting or underfitting due to the noise. And noise is basically irrelevant data that may be in the form of null values. So you have to make sure you get rid of them or replace them with average values in the column. And then there is redundancies like outliers, which are not necessarily required in your model, so you can remove them as well. So this is all about data cleaning. And then we have the third step, which is modeling. So for data modeling, first of all, you have to understand the relationship between the variables in your model so that you'll figure out what kind of model you're going to go for. So for example, if let's say if you have a target variable, in our case, which will be a price of certain goods. So let's say you have to figure out the relationship between variables. So if you're going for linear regression, you have to make sure that the relationship is continuous. And let's say if you are going for logistic regression, it is important that you go for continuous variables. The target variable although has to be dichotomous, or what you call it, categorical, which is like, let's say if I'm trying to predict something using the logistic regression, the answer would probably be yes or no, or be 1 or 0, something like that. But in case of linear regression, we have to make sure that there is some continuous relationship between the variables, which is my target variable and my independent variables. Taking a look at the fourth part, or the fourth step and the final step, is performance analysis. So after you're done making a model, so you have to perform certain analysis, which is, checking the accuracy of the model and making sure that it's above 70. I mean, if you're a beginner and if you are trying to make your first prediction model, anything above 70% accuracy score is very good, guys. But I would suggest that if you are working on a good model and if you want your model to be good, the accuracy should be ranging around 0.9, which is more than 90%. And if you get it the first time, it's well and good. But it solely depends on your data and the kind of model selection that you do. So let's take a look at the next topic in our session, guys. So this is basically where I'm going to perform predictive analysis using Python on a data set. So I have a problem statement in which I have a data set which has certain values or certain variables, which has columns like, how many bedrooms does a house have, and what kind of square feet it is grabbing, and all these things that I'll show you in the data. And using that data, I am going to predict the house of a price. So let's take it up to Jupyter Notebook, guys, and I'll show you what I'm going to do over there. So I have a Jupyter Notebook over here, guys. And if you're not familiar with Jupyter Notebook, guys, I suggest you to check out our tutorial on YouTube. We have a Jupyter Notebook tutorial. You will be able to learn it properly. I mean, there's not really so much to learn in Jupyter Notebook. It's quite easy. That is why I'm using also. And we have a cheat sheet as well, so you can go for that. So first of all, I'm going to import some dependencies. So for the first step, that is data exploration, I have to get the data. So for that, I'm going to use the pandas library, and I'll import a few other libraries as well. Like I'm going to use the Seaborn to check the relationship between the variables, basically for EDA, exploratory data analysis. And if you guys don't know what EDA is, I suggest you to check out another tutorial, which is exploratory data analysis, that we have on our YouTube channel. And then I'm going to import NumPy as well, just in case. All right. And you can see, guys, I have to just press shift and enter. And this is why I'm using a Jupyter Notebook, because the implementation is very easy and I can segregate my data or the code in different cells. So I'm importing this and I can just make it, okay, I'll make it a little bigger so that it's visible to you, everyone. What I can do is I can comment a part, let's say installing dependencies, and it is in a separate cell. So that makes it quite descriptive when you're coding, and when you are trying to figure out what's wrong in your code, it helps actually. So after this, what you have to do is I'll have to import the data. For that, I'm going to use the read CSV module, which is basically going to go to the file and read my data, guys. The name of the file is house.csv. We have a truncated error. Alright, so guys, I have to show you something. So usually when you do this, when you copy the file location, you get that Unicode error. But let's see if I change these backslashes to forward backslashes, what happens? Do I still get the error or not? Okay, we have right. So I was doing something wrong here. So this is one exercise for you guys. Like earlier when I was using the backward backslashes, I was getting a Unicode error, but when I change it to the forward backslashes, I'm not getting that error. So this is one question for you guys. Tell me why you think it happened in the comment sections below. Now moving on, I'll take the first look at my data, guys. So I'll just use the head method to get my first data. So these are the first 5 rows in my data, guys. So I have ID, we have date, the price is there, bedrooms, we have bathrooms, square feet living and square feet lot. We have floors as well. Waterfront is 0. Okay, it has to be 0 and 1, I guess. There is view, then grade, square feet above. So these are the columns that I have inside my data, guys. So I'll check the last 5 rows as well. For that, I'm using the tail method. So as you can see, you can get the first look of your data using the data.head and data.tail method. After that, I check the columns of my data, and let's check the shape as well, guys, so that we'll know what we're dealing with. Okay, it's not callable. All right, so we have 21,613 entries with 21 columns. Okay, it's a quite big data set, and let me tell you guys, this is one data set that I found on Kaggle, and it's very easy to find the house dataset, and I'm using this example of house dataset because it's very common, and to find this dataset is very easy. You go on to Kaggle and you just look for house prediction datasets, and it will show you a lot of datasets that you can download there from. Okay, so you can find the dataset on Kaggle, guys. Now we have checked the shape as well. Okay, I'll use one more method, that is data.describe. All right, this is callable. All right, so we have all these numerical values, and using the describe method, we can get the 50% minimum, maximum, and the standard deviation. We can get the mean value and the count as well. So let's say for bedrooms, the mean value is 3. The most common entry in the bedroom section is a 3-bedroom house. And then for bathrooms also is a 2-bathroom house. Square feet is almost 2079 square feet. And then for maximum values, we have even a 33-bedroom house as well. And we have a house with 8 bathrooms. And the square feet is 13,540. All right. So minimum value is we have a 0-bedroom house. Okay, that's going to be something else. And square feet 290. So this is how you use the describe method. And this is the first step, guys. I am trying to do the data exploration. Now after this, I think I'm pretty sure about what kind of data I'm dealing with. Now what I'm going to do, I'm going to move on to the next step, that is checking for the relationship between these variables. So for that, I'm going to use the data visualization, and I'm going to use a few plot points using the Seaborn library. And if you don't know about Seaborn, we have a YouTube tutorial on Seaborn library as well, so you can find out different kinds of plots that you can use for data visualization. And data visualization is nothing but it's a process where you can visualize your data, and you can try to figure out the relationship between the variables. Before that, I want to check for null values or missing values, because I don't want to get any hindrance in my data set while I'm modeling. So first of all, you have to do check for null values, and let's get a sum as well. So we have 0, almost okay. So we have no null values in this data set. So usually if you find a null value, and if it's a big data set, and let's say if all these values are, let's say 2000, and if you have 10 missing values, you can just remove those 10 values. But if there are more null values, I suggest you to replace them with the mean value. And to find out the mean value, you can just go over here. Let's say if you have let's say if you're checking for bedrooms, how many null values are there, and let's say there are 500 out of 21,000. So you can just replace the 0 with this value, which is 3, And similarly for any other column, you can do the same using the mean value. So since there are no null values inside this data set, because it's a very clean data set that I downloaded it from Kaggle, so we're going to move on to the next step, which is visualization. And mind you guys, this is the step in my data exploration part and the data cleaning part, not the other steps that we use for predictive analysis. All right. So I have no null values, but there are a few redundancies that I want to get rid of. I'll talk about that later, guys. First of all, I'm going to use a relation plot. X, I'll use, okay, so I want to check, or my basic aim is to predict the price of the house. All right. So for X, I'll just take price, and let's check the relationship between these variables. So I'll check for bedroom. All right. Kind is equal to, okay, we'll not use kind. Data is equal to data. Okay. All right. So I think we can, like, almost, there are so many, I mean, so this is one relationship that I'm getting over here. Price is not very clear, but we are getting the relationship of the bedrooms, or the most common bedrooms, so which is around over here, that is 0 to 5. And similarly I can check for other variables as well, like bathrooms. See guys, so the price is actually increasing with the number of bathrooms, but it's not necessarily same for everything. So there has to be some other dependencies as well, because as we can see, since the bathrooms are pricing, price is not actually rising that much. Okay, I'll just copy this. For bedrooms, the price is actually increasing pretty much with each bedroom. I mean, not really. If we take a look at 10 bedrooms also, the price is pretty much the same. So there's not one decisive factor I can think of for this. All right, so we'll check for some other as well. So we'll check for square feet living. So this is one linear relationship that I'm seeing over here, guys. So with each square feet rising, most of the prices are actually in this area only, like from 0 to 40, 400,000 or 40 million actually. But we can see that it's a linear relationship. With each increasing square feet, the price is actually rising. So this is one thing that has to be there inside our train set. I'll tell you what a train set actually is. Then there is floor as well. We can check for floors. All right. Okay, so floors is actually pretty descriptive over here. So for most of the values are in the 2 floors area, and then we can check for waterfront as well. Okay, we can do one thing. I'll tell you one trick. So we'll add the hue over here, and this is going to be waterfront. So with the houses which actually has a waterfront are in oranges, and the other ones are in blue. So you can see the relationship between them. And similarly I can use other, okay, so let's say latitude and longitude. So you can figure out the relationship between the variables using the visualization. So for me, I think in this data set, to get the price out, we're gonna have to use bedrooms, bathrooms. There has to be square feet. A lot of square feet has to be there. Floors also we can get, and then water view, front view, we'll use. Square feet we have to use, and year built and year renovated we can leave it out from the train set. And zip code also we don't actually need. Latitude and longitude are also not decisive in prediction, because we can use it for visualization, and we can actually get the picture over there. And square feet living is actually important. So these are the redundancies that I was talking about inside your model. So now we'll move on to the modeling part, guys. So what I'll do now is I'll import a few dependencies, guys. So from sklearn. So first of all, I have to import the linear regression from linear models. And I'm going to import linear regression. All right. So I'll import the model selection, import train test split. All right. So first thing that I have to do is I have to segregate my data into a training set and a test set. So I'll do one thing, guys. Right. So I'll get my data in this cell. So two things that I don't actually need inside my data are date, because I'll get the training data, or I'll write it as train. So which is going to be data, and I'm going to drop a few columns. So I'll have to drop a few columns. So first of all, I have to drop price because it cannot be in my training set since I'm going to predict it. And then there has to be ID. We don't actually need it. And then I'm going to drop date as well. There's not really prove a lot of things over here. So for now, I'll just remove all these columns. And for our test set or the dependent variable, let's say I'm going to take the variable as a test, let's say. And for this, I'm going to use data dot, or we need actually just one column, that is price. Right? Method object is not subscriptable. I'm sorry, I made a syntax error over here, guys. I have to add the axis as well. Now it's fine, guys. So now what I will do is I'm going to segregate my data into X train, X test, Y train, and Y test. And now I'm going to use the train test split method. So first we have train, then we have test, we have test size, which is, let's say, 0.3, and we have the random state is equal to, let's say, 2. Right, so we have made our xtrain and xtrain method. Now I'll use one variable, let's say regr regressor, and now I'm going to call my linear regression model. It's made, guys. So now I'm going to use the fit method to fit my xtrain and y train data, guys. The training data I have to fit. Right, we have no errors here, guys. After this, I can just okay, I'll take one variable, let's say predict, and regr dot predict x test and y test. All right, wait a second, guys, I'm sorry. So now the modeling part is done, guys. So I'll explain what I've done over here. I took the linear model, which is linear regression, and then for segregating my data into training and testing set, I'm using the train test split. Before that, I segregated the data for my model, inside which I'm using the training set, which has all the values from the data set except price, ID, and date. So I've removed these three columns because I thought these are redundant for my model right now. And the variable that I'm going to predict over here is the price. So I'm taking that alone. So after that, I use the train test split method to actually separate the data into training and test set. And then I call the linear regression model over here. Using the regression model, I am fitting the training data. And after that, I am using it to predict a value. So now comes the part where we have to check the efficiency of the model. So for regression models, it is very easy, guys. You can just check the score. For this, you have to provide a few values, X test and Y test. And we have the accuracy of 0.70, which is not bad, guys. If you're using the model or the data set this big, it is quite predictable, get this kind of accuracy. But you can do something else to improve the accuracy. I mean, you can look at the data and remove all the values that you find will help you into improving your accuracy. Like you can remove latitude, longitude, you can remove zip code, a year renovated, year built, that you can actually remove waterfront and view as well, or keep only a few values that you actually need, which is bedrooms, bathrooms, I think, and everything related to square feet. That if you keep in your training set, then it's going to be a higher accuracy for you guys. All right, so now that we are done with the session, guys, I want to give you a exercise sort of which you can do for practicing this. So I have used the linear regression model over here. So I want you to do one thing, guys. Check out other classifiers and regressor models that you can use to predict a value. I mean, we have a tutorial on all of them on our YouTube channel, and see if you can use the same data to make a prediction model using other classifiers like a random forest classifier. Then we have a decision tree. Then you can use logistic regression for this as well. I mean, if you have continuous data, then you can go for linear regression. But if you find a categorical data, let's say we have waterfront or not, so you can check for that as well.
To start with, we are going to start with the statistical functions. The first one is average function. What does the average function do? It's an inbuilt function in Excel that is categorized as statistical function. Average does exactly what it says and works similar to sum. It will return the average value of the given series of numbers in Excel. Let's say we need to identify the average salary paid to the employees in the organization. Where is our salary data? In the H column. So what I'll do is I'll enter the average function followed by the open bracket. In the cell, we need the result. In our case, it is J2. So I start with an equal to, I enter average, open the bracket. Now I'll have to select the range of cell for which I need the average. And in our case, it is the salary column, which is H to H. I close the bracket and press enter. I get the average salary as 15,538. This is the average amount paid to each of the employees in the organization. The next function in our list is the median function. The median function is again a statistical function which returns the median of a given number. What is median? It is a middle number in the set of numbers. That means if I have 10, 12 and 15. So there are three numbers that I have to identify the middle number from this. So is equal to, I'll use the median function here just to identify what is the middle number and then select the range of cells that has numbers. Close the bracket, enter, it will give me the middle number, which is 12 in our case. Because it is not the highest, it is not the lowest, but the middle value. The same goes if I want to know what is the middle value in the salary column, I'll use the median function in cell L2. Is equal to median, open the bracket, select our salary column, which is H to H, close the bracket and enter. 15,750 is the middle value of the salary column. Next we're going to see is the mode function. The Excel mode function returns the most frequently occurring numbers in the numeric data set. This function only works with numbers. It will identify amount or the number that occurs maximum time in the range of cells. So for example, here we have the basic salary where I can see the highest number is 49,000 and then there are few employees earning the same salary, but I want to identify which salary is being earned maximum time by the employees. So I can use the mode function as equal to mode, open the bracket. It is only mode. Select mode, open the bracket, and then select H to H column because I want to know from the salary column. Close the bracket. 17,500 is the amount that occurs maximum time in this cell ranges. Moving on to the next one is the standard deviation function. What is a standard deviation? It's a formula is to identify the standard deviation of the set of numbers. The standard deviation function calculates the standard deviation in the sample set of data. Standard deviation is a measure of how much variance there is in a set of numbers compared to the average of the numbers. Standard deviation .s function is meant to estimate standard deviation in a sample. If the data represents an entire population, use the standard deviation .p function. So we will look at a standard deviation sheet. Here I have a sample data. So sample of few students have been picked up who have scored a particular number or a particular marks in the different subjects. So we have taken a sample and we have not picked up all the student data. So if we are using it for a sample only, we will use the standard deviation, which is standard deviation .s. It estimates standard deviation based on the sample, ignores logical value and text in the sample, so it has to be only numbers. Okay, so it's standard deviation dot s when you have a sample data where you just want to identify how much variance is there as compared to the average, you will use the standard deviation dot s. But if you have a full population, that means if you have all the marks of all the students in the school or the college, you will have to use standard deviation dot p, which is also there here. Calculates the standard deviation based on the entire population given as an argument. But here we are using the standard deviation for a sample data. So I select that, and then for which I need a standard deviation, I'll just go and select that particular range. I close the bracket, I press enter. It is giving me 4.89, which is a standard deviation value for that scores. So this is how your standard deviation works. Next function that we are going to see in our list when we are going through our function list is our large function. What does a large function do? Large function returns the nth largest value from the sample. For example, if I go back to my data where I have the salary data or the employee salary list, I have to identify what is the highest salary that I'm paying. I can do it by using the sort and function, but it can be that as of now I have sorted this data, but later on this person has Asha Trivedi has moved to a different department. Director Sheetal Desai has left, and Asha Trivedi has moved into being in the board of directors list. Not only Asha, we have also identified Bharat to move into the board of directors. So now we have two board of directors, but both their salaries will be a little different. Say I will change the board of directors salary to 51,000 for Bharat, and for Asha Trivedi it is about 60,000. So this is the salaries that we have decided for the board of director, which are two board of directors. Now, in this case, if I have to see the first value, first find out what was the largest value in the salary section without changing the two values that I had now. So is equal to large, open the bracket, I'll select the array which is our salary, and K, when I say, what does the K mean? K mean I have to tell which highest number. That means if I want to know the first highest value or the first largest value from the list, I can put the number as 1. But if I don't want to know the first largest, I want to know the second largest salary paid to the employee, I will press number 2. Close the bracket, enter. Now if you see, our largest value is actually 49,000. However, the answer that you get is 24,500. Why? Because we are looking at the second largest value in the range of cells. If I am looking at fifth largest value, I'll put it as 5 and press enter. It will give me the fifth largest value in the set of cells, so which is 22,750. Like in our example where I mentioned that Asha Trivedi is now moving to the board of directors. Let's not remove Sheetal Desai for now. She's still there in the board of directors. We also move Asha Trivedi to the board of directors list, and this time the board of directors salary that I'm moving to is 60,000. So when I say the board of directors salary is 60,000, when I move this salary now and say that which is the first largest salary, the first largest salary will be 60,000. The second largest salary will be 49,000 instead of 24,500. Why? Because now there is even one more larger salary. The first largest salary has become Asha's salary, which is 60,000. Earlier it was 49,000 was the largest. So this way, if you keep on changing anybody else's salary, say I make it to 65,000, just to get a gist of how it works. If you will see that earlier it was 49,000 was the largest. Now the 60,000 has become the largest salary or the second largest salary. Same goes with the small. I am trying to identify what is the smallest salary that I'm paying or the lowest salary that I'm paying to the employee. Now, again, I have to give the K value. Now, K value, again, like I said, it will be the value of which smallest number that you want. Is it the first smallest that you want to know? Is it the second smallest that you want to know or the lowest that you want to know? Is it the third that you want to know? So according to what is your requirement, you can put the number there as, say if I put 2, so it will give me the second lowest salary paid to the employees in the organization, which is 7,000. If I make the lowest salary as even more lower, so let's see what is our lowest salary. It is 5,950. Let's make one of them to 5,500. what will happen is now if I go back and see the second lowest salary value, it is now 5,950 because the first has now changed to 5,500. So depending on how your value is, which is your lowest salary, it will automatically calculate and give you that number. So moving on to the next one, which is our choral. What is choral? Or it is the correlation, you can say. We can use the correlation function in Excel to find the correlation coefficient between the two variables. I'm sure we have all learned coefficient correlations in our college days when we were doing maths in the college. If you had opted for maths in college, you would have done the correlation coefficient. However, if you're not done it, which is not a big deal, the Excel is already doing it for you. Correlation coefficient formula are used to find out how strong a relationship is between the two data. Like here in our case, the relation between the age and the relation between the glucose level of the person. Is it that the age increases and the glucose level increases, or is it that the age decreases and the glucose level decreases, or is it that the age increases and glucose level decreases and vice versa? So depending, we are trying to understand what is the relationship. Formula always returns a value between -1 and 1. What is the relationship of -1 and 1? Why is it always giving you in -1 and 1? And how is it bifurcated or split? If your relationship is 1 or close to 1, rather I would say 0 to 1, it would indicate a strong positive relationship. A correlation coefficient of 1 means that for every positive increase in one variable, there is a positive increase of a fixed proportion in the other. For example, shoe sizes go up in perfect correlation with the foot length. So when your foot length increases, your shoe sizes increases. So it's a proper correlation. That is when your one correlation, it is exactly how much your foot sizes increases, your shoe sizes increases. If the correlation coefficient is -1, it indicates a strong negative relationship. A correlation coefficient of -1 means that for every positive increase in one variable, there is a negative decrease of the fixed proportion in the other. For example, the amount of gas in the tank decreases in perfect correlation with the speed. Every time the amount of gas in the tank decreases of your car. So when you're running the car, if you're increasing the speed, your gas keeps on decreasing. Why? Because you're increasing the speed. So the gas is getting used or your fuel is getting used. And that's the reason the fuel is decreasing, but your speed is increasing. So there is an opposite reaction. Fuel decreases, but your speed increases. That's how your coefficient correlationship works if in case of -1. If the result is 0, it indicates no relationship at all. 0 means that for every increase, there isn't a positive or negative decrease. The two just aren't related. Anything that is 0, no relation at all. 1, where there is a positive relation. That means with the increase, the other part will also increase. While with -1, it is the opposite side. With one increase, the other one will decrease. That's the three differences that you will see. Of course, you will not get the result as 1, -1 or 0. It will be in between. So we will try and understand that if it is between 0 to 1, then it is a positive one. If it is between -1 to 0, then it is -1. And if it is 0, then it is no relation at all. So let's see an example in our sheet where I have the age considered as the X value, age of the person, and then I have the glucose level of that person as considered as Y. We are just trying to identify what is the relationship between the human age and the glucose level in their body. So if you see the human age, the X level, it says 43, the glucose level goes to 99. 21, the glucose level shows as 65. But does it make sense by just looking at it? Because we can't identify what is the relationship. Is it -1, is it 1, or is it 0? So to identify that, I can use a function called correlation function, which is correl in Excel in the cell where I need this result. So is equal to correl, open the bracket, and then I will select the different arrays for which I need to identify the relation. So first relation that I have to identify for is the age. So I will see that age against glucose level. So the age is sitting in B2 to B7. So I'll select that as the first array. The second array is C2 to C7. So I select that second array, which is C2 to C7, and close the bracket. Press enter. It is giving me a value as 0.53 if I remove more decimal places that I have. So our answer is 0.53, which is a positive result. That means there is a close relationship between the age and the glucose level. When it is positive, it means that the increase in age does increase the glucose levels in the body. If this was a negative point, then it would have been the other way around. That increase in age reduces the glucose level in the body. So this is how your correlation function works. Let's see another example that we have on our sheet, which is a correlation function. We have the price of the stock A that changes, or the percentage change in the price of stock A. And then we also have S&P 500 weekly change, or the percentage change of S&P 500. The S&P 500 is a stock market index that tracks the stocks of 500 large cap US companies. It represents the stock market's performance by reporting the risk and returns of the biggest companies. So what are we doing here is we are identifying if there is any relationship between the S&P change and the stock A change. So if there is a relationship, they will be able to take a proper decision in the future when they are making some investments. So to start with, I am going to find out the correlation. So I'll do is equal to correl, open the bracket. Now we have two set of data, which is two arrays. So I'll select the first array as this one, which is C5 to C24, comma, the second array will be D5 to D24. I close the bracket, I press enter, you will see that it is very close to 1. So it is 0.89, or rather 0.9. This means that every time there is a 1% increase in the S&P 500, then there is 1% increase in the stock A prices. Similarly, if there is a decrease in the S&P 500, accordingly the stock prices of A will decrease by 1%. That's how the exact correlation is. While in the previous example, there is 0.5 correlation. That means when there is a 1 year increase in the age, 0.5% of increase in the glucose level. So that's how the correlation is identified using the correl function in MS Excel. Next, we are going to see the charts in Excel. What are charts? When you want to graphically represent some data, it is very difficult to interpret Excel workbooks that contains a lot of data. Charts allow you to illustrate your workbook data graphically, which makes it easy to visualize comparisons and trends. Excel has several different types of charts, allowing you to choose one that best fits your data. In order to use charts effectively, you will need to understand how different charts are used. So we will start with the column charts. So you'll see all these different types of charts that we are going to learn today. So to start, we'll go back to our example sheet where I have the sheet for column chart. That means there is a data that is already available where I have the data for the region along, or rather the sales data for each region, which is split into 2 years, which is 2016 and 2017. This data is in millions. So you can see that the Mumbai has done a sales of 65 million in 2016, while it has done the sale of 70 million in 2017. Same goes with London. It has done 55 million in 2016, while in 2017 they have done 65 million. USA, you can see 45 million and 52 million. While if you see Nagpur, you will see that the sales have reduced from 2016 to 17. Here, this is smaller data, so you're able to even identify where it is going wrong and how is it related, how is the comparison done. So instead of doing that, if you want to send it to your management, you can just select this data and create a chart that will show exact comparison on your screen, and it will represent it graphically. So how do I do that? I go to insert. In 2016, there is a new option that has come up, which is called as a recommended chart. That means whenever you select any data and then click on insert, it will give you an option as recommended chart where the Excel will recommend you the types of chart that will look good with these kind of data, or rather it will properly represent this data which you are looking at. So I select the data that I want the graph for, and then I go to recommended charts. When I go to recommended charts, you will see that there is the first chart that it is recommending is the column chart. This is your column chart. But as we are now seeing the column chart to start with, or each type of chart, we will start with the column chart for now, and then we'll come back to the recommended charts. So you'll see the first one, the column chart is here given in the icon for 2016. First 2D chart that you can see is the column chart. I click on that and the data is coming next to one another. When is the column chart really useful? The column chart is useful in such kind of datas where there is a comparison required. So column charts use vertical bars to represent data. They can work with many different types of data, but they are most frequently used for comparing information. Like in our case, 2016 and 17. So I have got this data as column chart and it is comparing between the 2016 and 17. Now looking at this chart, it looks very nice. However, you will see there is something missing, as in when I'm looking at the data for Mumbai, if I don't see this table, I will not be able to identify what is the real sale done by Mumbai. I'll have to mouse over it to get the number. When I mouse over it, it says series 2016 point Mumbai value 65. It gives you all the data. However, if I am just outside this data, I will not be able to see the information on in one go. It just shows which one is the smaller value. In Gujarat, I can see that in 2017 they have done less sale as compared to 2016. But I need the exact number. So for exact number, what I can do is, one way of doing that is I can go and look at it by doing a mouse over it. Another way to do that is to just see it. I can add the data label. How do I add a data label? There are different ways to add a data label. One way to do that is first select where you want to add the data label. Say I want to add the data label for 2016 and 17, both the bars. So I cannot do it together. So what I can do is I can select one at a time by using the left click and then right click on that same data and then click on add data label. Once I do that, it will add those numbers on that data. Secondly, I can do it for 2017 also by selecting it. However, there is another way of doing it. If I now want to delete the data labels, I'll just select and click on delete from my keyboard and it will work. Now, I do not have the data labels here. I want to add it using this plus sign. It's only available in 2016. When I select the chart, there is an option as a plus sign. I click on plus and I click on data labels. It will automatically add data labels for both the bars. I don't have to select each of the bars. This is how your data labels are added. Now, if you can see, there is a axis Y which is given here, which has some numbers. Why those numbers are there? Because earlier we did not have data labels, and that's the reason we could see with these numbers where our data sits. So just above 60, somewhere between 60 and 70. So I assume that it is 65. So that is how it was showing. However, now that I have the data labels, I will not need this information, or I will not need this access on the left hand side. So how do I remove that access from the left hand side that you can see there? There are, again, one way of doing that is going to the design mode, which is after you select the chart, go to design mode and then under add chart element, I will see axis, which is the x-axis that we used to call. Another one is the primary vertical axis. Vertical axis is the vertical which is on the left hand side that we were just talking about. This one. This is your primary vertical and this is primary horizontal. So I want to remove the primary vertical. As of now, both are highlighted. That means both are there. I want to remove the primary vertical, so I select that. It just goes away. That's one way of doing it. Easier way or the quickest way to do that is just select the axis. Be very careful that only the axis is selected. You will see that four small ball kind of a thing that comes on the four corners of that axis. Once I do that, once I select that, I can press delete DEL from my keyboard and it will go away. Third thing that I can see on this chart is the chart title. I have to add a title to this chart. So how do I add a title? It is already there on the list. I just have to add the title. I select the data there and add the title as sales comparison or sales for 2 years. And in the bracket, I'll put in millions so that they don't get confused that why is it showing as only 50, 40 or whatever. So this is how I can show my data. One more thing that I would recommend doing is removing these grid lines. The grid lines will be more useful when you don't have the data labels because then it gives you where exactly your data sits. With the y-axis, you'll be able to see the number. But when I don't need this grid lines at all. So I'll just select the grid lines and then click on delete on my keyboard. That's one way. Another way to do that is just go to that plus sign and press the grid line. Grid lines are there by default. Now if you see the data, it looks even more cleaner, or it looks even more presentable because there is no grid lines at the back. It's all clean. This is how you can tweak your data as per your requirement. This is how your column chart works, but you can do the same thing with the other charts as well. There are other quick things that you can do with the chart is by also changing the chart type if you want to, or changing the data that you have selected. So you have selected this data in order to get this chart. However, I want to change the data. So I can click on that design. In the under design, you will see under data, select data. Once I click on that select data, it will give me an option here to change the data range for the chart. So I can click on this data range to change the chart. Very important part that you will see here is switch row or column. So what happens is, as of now, my y-axis only contain the numbers and the x-axis contain the Mumbai, London and everything, and the data which is the colors or the bars which are there that are in the colors, that is 2016 and 17, which is the year is showing in two different bars. Now when I click on this switch row and column, what will happen is all the region which is there will become your color of the bar or different bars, while your 2016 and 17 will come on the x-axis. Let's see how that happens by just clicking on switch rows and columns. Once I do that and click on OK, you will see that 2016 data is showing under the x-axis and all the bars are showing now with the regions. This also can be done. However, in this case, it is a little difficult to identify the or do the comparison between the 2 years. You can do comparison between in 2016, what is the sales that you have done for each region. That kind of a comparison can be done to identify. If you see, Gujarat has done the lowest sale in 2016, while again in 2017, Hyderabad has done the lowest sale. So this kind of comparison can also be done, but depending on what kind of a comparison you're looking at, you can always click on switch row and column. You can also use this button to switch row and column. Otherwise, you can click on select data and then use this information. This is how your charts will work in Excel and how you can add new data into or data labels, how you can format your data using the different data sets under design. Moving on to the next chart, our next chart in the list is the line chart. Line charts are ideal for showing trends. Like you have in our list, I have the number of days and the temperature that is changing as per the number of days on day one. So we are trying to say maybe in December. So in USA, we have this days. If you are trying to see that on day 1 of December, if I start with day 1, what was the temperature and how is it going up or is it going down? So that kind of information, if I'm trying to identify, I can use the line chart because the line chart will give me a kind of a trend on different days. So how do I create a line chart? When we have the data where we have to show the trend in a particular time frame, that time we are going to show it as in the line chart. Like for example, in our sheet, we have the days from day 1 to day 6, identifying what is the temperature like in these days. So we have a trend, like in this first day it is 43, the next day is 53, third day it is 50, then fourth day it again goes up by 57, fifth day it going up 59, and then sixth day again it is 67. We're just showing a trend of the data. In that case, I'm going to use the line chart. So I'll use the line chart by selecting the data. It is giving me the line and it's showing you how it is going up. So it starts with the day 1, it is lower, then it goes higher and then it keeps on going higher, higher, higher. Only in the day 3, it dips a little down, but it keeps on going after that. This is how your line chart works. So whenever you have this kind of a data where you have to show a trend, we are going to use the line chart. What is the next one? The next one is a pie chart. Pie chart make it easy to compare proportion. Each value is shown as a slice of a pie. So it's easy to see which value makes up for the percentage of the whole. So for example, I have this book type, which are the book types that is being sold by the bookstore, which is the classic, mystery, romance, science fiction, and spiritual. The revenue that is generated out of these books are also listed here. For classic, it is $18,500. By mystery, it is 78,970, and so on and so forth. I'm trying to identify what is the total revenue that I have generated, which book type is giving me the maximum revenue, while which book type is giving me the lowest revenue. To do that, I can use a pie chart because it's going to give me the part of a pie. Like here, you will see that the orange part is actually the mystery part. Mystery is being sold maximum time part of the time, and the revenue is also generated. Now, similarly, like we did it for the column chart, you can also use the data tables in the pie chart as well. How do we use the data tables in pie chart? By again using that plus sign on the right hand side, or just right clicking and selecting the add data label. As of now, we'll use the plus sign and click on the data labels. Once I do that, the data labels will be added on the list. Now in this case, the numbers are being added. However, I also want to add the chart title. The chart title is also already mentioned as the revenue. So we can leave it as it is. If you need to change that, you can always double click inside and start changing the name of the chart as well, or the chart title. In the data labels that we have added, you will see that only the numbers have been added. I have to check which color belongs to which in order to see where does the highest number land. So if there are bigger lists, there are only 5 different lists, so that is fine. So if there are about 10 to 12 lists and you want to see which one belongs to which, it is a little difficult to identify that. So what I can do is I can add the chart labels on each of them, like a data labels. I can also add the labels on each one of them to identify how does that look. So how can I do that? By going to the data labels in the add chart elements and then click on more data labels option. As soon as I do that, a new window or a new level has opened up on the right hand side. I can select the category name. What will happen is as soon as I select the category name, it automatically gives me the category name in the list. Now the category name you can see is separated by a comma and it is coming next to each other. If you want to change the separator, you can use any of these as a separator. I can use new line. So what will happen is the number will go in the new line. So it looks a little better. Again, like the earlier one where we removed the x-axis, in this case, now we have added the names on the chart itself. So I can remove these legends from the bottom. So it looks a little cleaner. Now I can even make this a little bigger because we have enough space to make it bigger as I have removed the legends from the bottom. So this is how your pie chart will look. Moving on to the next one. The next one is a bar chart. Bar chart works just like the column chart, but they use the horizontal bars instead of the vertical bars. Where is it useful? But it is useful in the data where you have the bigger names of the headings, like in this case. Yes, the inbound marketing demonstrator ROI. If I insert the normal column chart like this, now your the data is smaller, so it is just giving you in that same line. However, if you have a bigger data, or even it will look better if you have the bar charts, which is shown in the horizontal level like this, because you can clearly read the headings here on the left hand side and your bar charts goes on the right. Again, removing the grid lines, adding the data labels will remain the same. Moving on to the next one, that is the surface chart. What is a surface chart and how is it useful? Surface charts are useful when you want to find the optimum combination between two sets of data. Like in our list, we have the marketing, finance, and effort, and they are which field is used or which department is used to get these details, like recruitment, how much you have to recruit in these three departments, which is the financial, marketing, and the effort. How much contribution is of the environment in the financial, marketing, and the effort, how much assets are there in the financial, marketing, and the effort, and the building, how much is there, and the expenses that has been formed part of these three departments. So if I want to know these, so I'm trying to combine the recruitment part, I'm trying to identify the combination of marketing, finance, and effort, how much recruitment has been done in the combination of all three. In this kind of a situation, I'll be using the surface chart. So how do I use the surface chart? Where is it located? Again, if I go to recommended chart also, I'll be able to see the surface chart under recommended chart. Under recommended charts, there is a window or tab called all charts. I can select that, go to surface. Here I'll get that option of 3D surface. I click on OK, you will be able to see the surface chart here. So it gives you the effort, marketing, and finance. So you will see that the combination of the recruitment here, which is this part, is showing your total recruitment done for all the three departments. Same goes with environment, how much environment is affected due to finance, marketing, and effort, asset that has been used by these three departments, and so on and so forth. So how we are adding the values to this. So this is how it shows. You can again remove the grid lines if you want from this list so that it looks a little better. And it also gives a number as 0 to 200 as blue, which is this part, because the 200 only is affected. When I say 0 to 200, this is the effort is 159. That's the reason it is showing as 0 to 200. The second one is marketing, 200 to 400, which is 345 in case of finance. So that's a little bigger it is showing here, the orange one. The next one is actually your gray, which is 400 to 600, which has got a little even bigger. So this is how your data is identified by using the surface chart. Moving on to the next one. So we have learned how the charts work in Excel and how you can make a little bit changes in order to identify the best chart that fits into it. You can also use the change chart type option to change a particular chart. So if you think that the surface chart is not fitting into this, you can select the chart and click on change chart and then use one of these recommended charts from the list. This is how we learned the charts today. Let's move on to the next one, which is the pivot tables. What is the pivot table and how is it useful in your day-to-day life? Many people have the idea that building a pivot table is complicated and time consuming, but it's simply not true. Compared to the time it would take you to build an equivalent report manually, pivot tables are incredibly fast. If you have well organized source data, you can create a pivot table in less than a minute. So let's see how you can do that. First of all, I have a sheet with all the data information there. Like in our sheet, I have the list of employee code, their names, so department, region, branch, and their salary information. I am going to create a pivot table in order to show the different departments' salary, how much salary are we paying to different departments. However, before I do that, I'll have to show you how to create a pivot table. To create a pivot table, I first will go to the database for which I need to create the pivot table. So I go to the database, I click on insert. After I click on insert, there is an option called pivot table. I click on pivot table. A new window will pop up. In the pivot table wizard, I have to select the table or the range for which the pivot table is to be created. So I select range A1 to H101. The next one that I have to select is either the new sheet or the existing sheet. New sheet, that means when I click new sheet and click on OK, it will automatically create a new sheet in the existing workbook and the pivot table will be placed in that new sheet. However, if I click on existing worksheet, I have to give a new location. That means the sheets that I already have on the workbook, from that sheet, which cell do I need the pivot to be placed? Hence, I will click on the location and select the location that I need the pivot table on. I can select from any of the existing sheet that I have on the workbook. However, this time I'm going to use a new worksheet and click on OK. This will create a new Excel sheet for me just before the Excel sheet that I was working on currently. So it is now creating that Excel sheet. Once the Excel sheet is created, on that sheet you will see the pivot table wizard is already available, or a blank space where it will show you the pivot table number. And on the right hand side, you can already see the pivot table fields that are shown. Under the pivot table fields, all the headings which were there in the database have already occurred here, like employee code, first name, last name, department, region, branch, hire date, and the basic salary. So everything is already showing here. Now, before we start with the pivot table, we need to understand these four fields that are there on the pivot table. So every field has its importance. So let's start with the values area, which is this one. The values area is the large rectangular area below to the right of the column and the row heading. The values area calculates and counts data. That means anything that you enter here, it will give you the calculation of that value. For example, if I pick salary, which I drag and put it on the values column, it will automatically give me the sum of the salary. You can see it says sum of basic salary. That means the total salary that has been paid. You can change this to any other field. For example, if I click on this and click on value field setting, I can then give other calculations, right? Count, average, max, min, standard deviation, anything that I need in this field, I can select and give that option. If I don't want the sum of the salary, I just need to know the count. Can click on count and it will give me the count of that cells which has the salaries. So I click on sum for now. The data field that you drag and drop here are typically those that you want to measure. Fields such as sum of revenue, count of units, or average of price. Row area, which is this part. Placing a data field in the row area displays the unique value from that field down the rows on the left side of the pivot table. That means because I said that I want to do it at the department, when I drag it to the rows, it will pick up all the unique values. So even if admin is coming 10 times in our database, like admin comes a lot of times here, it will only show once in the pivot table. Same goes with CCD, to same goes with the director. What does that mean? It will group all the admin together. Then it will sum the salary of admin, the next cell where I have done the values, and it will give me the answer here. So it will giving me the salary for only for admin, then for CCD, then for director, finance, marketing, personnel, R&D, and sales. This is how your database will look if you put the data into the rows area. Next is the column area. The column area is composed of headings that stretch across the top of the column, which is this. So if you want to give a heading other than this, if you want things like region to be shown in the column. If I put column, what will happen is now it will show me the east, west, north, south. It will be split as per the east, west, north, south in the column, and it is kind of heading that is given on the top. Like for east and admin, this is the total salary. This is how it is giving you the split. Next one is the filter column or the filter area. Filter area is an optional set of one or more drop-down list at the top of the pivot table. Here the filter area contains the region field. The pivot table is set to show all the region like this. If I put it on the top here, it is actually an optional area, but it will only show me the region on the top. Then it will not show in the column. The filter area allows you to easily apply filters to the pivot table. For example, if I leave my region here and try to put a branch in the filters column, I can select which branch I need the data for. For example, if I need only for Ambala, I can click on Ambala and click OK. It will only give me data for Ambala. Same way, if I select the rest of the other data, it will give me the list for other. If I want more than one data, I'll just click on select multiple items and I can select 2, 3 at a time and then it will be filtered as per the branch and give me the rest of the data. This is how your pivot table actually works. Like I said, you can use these value field settings to get the other calculations to be done with this value field setting. This is how your data or the pivot table works. Now, this was a simple part of the pivot table. If you ever want to sort on the pivot table, let me first remove the region to make it look easier. So to understanding will be more easier. I'm removing the branch from the filters as well. I'm just leaving the department and the sum of the basic salary. Now what I'm trying to do is I'm going to filter as per the salary. So I want to understand which department I'm giving the maximum salary. I select the salary column or I just click or keep my cursor in the salary column. I go to data and the same way as we do the sort, I'll just click on sort there. Once I do that, it will give me a wizard where I have to select whether you have to sort as per smallest to largest or largest to smallest. I will do is largest to smallest. And I can see that in the sales department, I'm giving the maximum salary, which is 3,45,075. So this is how your sort works in the pivot table. So there are other things that you can also use in the pivot table, which are really, really important that we are going to see here. There is something called as a slicer in pivot table. What is slicer in pivot table and how does that work? When you go to analyze data, there is an option called as insert slicer. If you are anywhere outside the pivot, you're not keeping your cursor in the pivot, you will not be able to see the analyze button. To go to the analyze button, you have to click on the pivot table and then click on analyze. Once you click on analyze, there will be an option called as insert slicer. Now, insert slicer in the sense it's a kind of filtering of data. So the same way, similarly, like I did it for putting the branch on the top or the region on the top where I could filter the data, I can use the slicer to filter this data. So if I click on slicer and select which field I want to filter it with, like if I want to filter it with the hire date, I can select on hire date and click OK. Now it will give me a slicer or the list of hire dates which I can select from. So if I select only this hire date, it will automatically give me data for only the employees who have been hired on this particular date. So this is how your slicer works. However, now you can see that in the slicer, okay, I can only select one data or one date at a time. But if I want to select more dates, then there is this something called as multi-select, which is on the top right-hand corner. This is only available in 2016 version. So when I click on multi-select, It will give me options to select multiple dates at a time in the slicer. So it is not necessary that you have to only do the dates. You can also add some more information other than just the dates. Click on analyze, I go to slicer again, and now I can select anything else that I want. Now department is already there. I can select maybe branch this time. So it will give me another slicer. So you can see the another slicer which is there here. So there are two slicers now. So not necessary that you have to only work with one slicer. You can work with two slicers or multiple slicers. I select Calcutta and Darjeeling, and it gives me data for the Calcutta and Darjeeling for these two dates only. If I select one more date, it will give me data for Calcutta, Darjeeling for these three dates. So the slicers can be multiple slicers on the list, and it will give you information as per your requirement. How to create a chart from the pivot table. And it also looks the same as a normal chart. So when I click on the database where I want to create the pivot table from, and I then click on the pivot chart by going to analyze button and then pivot chart, it will automatically create the chart that I want to. Similarly, as we get the column chart in this case, so I click OK. Once I do that, it will automatically create a chart. In the chart, you can, similar to the normal chart, you can give the name as a chart title that we are looking at. Add the data labels by clicking on this plus sign and click on add data or just add data labels. Once you do that, the data labels will be added. All these fields which you can see, sum of basic salary, department, if you don't want to show it on the table because it is a pivot tables chart, it is giving you these information also. If you want to just hide that, you can right click and click on hide all field buttons from chart. It will automatically hide those fields. Now, if I add any additional information, like in this one, you can only see that the sum of the basic salary is given. There is nothing on the row columns. So what I can do is I can also add data in the row. Once I do that, it will automatically update the pivot chart as well and give me the information as per the row column also. Now, again, like where we had used or changed the chart type by selecting the data and switching the row to column, you can use a similar function here to switch from row to column. So here the data will show in a different way altogether. So as you update your pivot table, your pivot chart also keeps updating, and all the same functionalities that is available in the normal chart is also available in your pivot chart. The only difference is that it is linked to your pivot chart, the other data is linked to your database. That is the only difference. But pivot chart, when you are looking at that, it is very, very useful because your pivot chart is on updating as per the new data that is updated there. Also, you are only giving the information or you are only requesting the information that you want in the chart rather than everything coming into the chart and then you selecting which parts you want to display. So that's how your pivot table and the pivot charts work. If they are really, really useful in your day-to-day reporting that you do for your companies, and it will really help you to do that. Now we have also learned how to do the pivot table and how to use the slicers in the pivot table. There is another important part of the slicer is that you can link two pivot tables to the slicer. For example, here I have one pivot table which is splitting the department and giving you the total salaries as per each department. Now I'm creating a new pivot table from the same database. Say I just copy and paste, that will also give me another pivot table. But I do not want department. This time I want to know the salaries given to the employees in different regions. So this is split as per the region. The slicer that I can add here is by clicking any pivot table I can select and then click on slice on analyze and then click on insert slicer. The slicer will be as per the region or the date or the last name, whichever you want to. As of now, I'm selecting the branch and click on OK. Once I click on branch, it will give me the options of the branch with which I can select and analyze the data. But what I need now is I want to link this pivot table, which is a pivot table 2, to pivot table 1. That means when I select Ambala, you will see that only second pivot table has given me the data for Ambala, which is the north region. The first pivot table stays as it is because this slicer is only linked to pivot table 2. I want to link this slicer to both the pivot tables. How can I do that? I will have to click on the slicer, right click on that, then click on report connections. Once I click on report connection, it will give me the list of pivot tables available in your workbook. Now we know that in the sheet 1 we have both the pivot tables. Sheet 10 is not our sheet. So both the pivot tables are in sheet 1. So I'll select both the pivot tables from sheet 1 and click on OK. Once I do that, now I will be able to link both the data. And now when I select Bangalore or one branch, it will automatically give me data for that one branch. Just like that, Cochin, it will be giving me data for that one branch. Same goes with Ambala or Aligarh, and if I select more than one, it will give me all the ones selected and give me data for that 2 or 3 branches that I had selected. So basically what I'm trying to say is you can connect 2 or 3 pivot tables to one slicer so that you will be able to get the filters with one slicer for both the pivot tables. So this is how your pivot table is, or the slicers are useful in case of trying to get the filters for your data. The next topic that we are going to see today is the data analysis using Excel. So how do you do a data analysis using Excel? So there's something called as the analysis toolpack in Excel through which you can do the data analysis. The analysis toolpack is an Excel add-in program that provides data analysis tools for financial, statistical, and engineering data analysis. To load the data analysis toolpack, you have to execute some steps in Excel. So how do you do that? Let's go to our Excel. On the File tab, I click on the Options. Once I click on the Options, under the Add-ins, select the Analysis Toolpack and click on OK. So when I go to Add-ins, under the Analysis Toolpack that you see here, under the name where you see Add-ins, select the Analysis Toolpack and click on Go button or click on OK button. Once I click on OK button, what happens? It will open the new data for you or the new window for you. Click on Analysis Toolpack and click on Go. Once I click on Go, it will give you that option of Analysis Toolpack, Analysis Toolpack VBA, Euro Currency Tools, and the Solver add-in. I will add the Analysis Toolpack and click on OK. Once I do that, now I will be able to see that under Data, there is something called as Data Analysis added to my ribbon. So you can now click on the data analysis to create your different analysis that you want to do from the list that you have. Now let's see how we can create data analysis using the Excel data that we have. So what do we have here? On our Excel sheet, I have a list of data like I have the quantity sold, the price of the product, and the advertising. Now this example teaches you how to perform a regression analysis in Excel and how to interpret the summary output. So now in the below data we can see here on the list, the book question is there a relation between the quantity sold and the price in the advertisement? So what is it? Is there a relation between this and the output is? So what are they trying to understand is if this is the price and this is the kind of advertisement that we are doing, or this is the amount that we are spending on the advertisement, is the quantity sold increasing or decreasing, or any relation that we are able to see? So can we predict the quantity sold if we know the price and advertising? So if I know only these two things, can I predict what will be my quantity sold? That is, to do such kind of analysis, we can use this data analysis toolpack. So I go onto the data tab in the analysis group and click on data analysis. Now select the regression from this list and click on OK. Now there is a range that supplies some basic regression statistic. So how do you do this? Now there are two things that we have to give: the input Y range and the input X range. This will always be by default blank, and we have to give the ranges to the Excel. So how do you give the range and how do you decide what should be the range? So the first thing that we'll give to Excel is the Y range. Select the Y range A1 to A8. This is the predictor variable, also called as the dependent variable. So this is something that we have to predict. It is dependent on these two things. We don't know the quantity sold. We are trying to understand what will be the quantity sold if we have the price and the advertising. So your dependent variable will be your Y range, which is your A2 to A8. Second one that you have is the X range. These are the explanatory variables. These are also called as the independent variables. These columns must be adjacent to each other. So whichever you're selecting. So I am selecting C8. These two should be adjacent to each other. Now I have to ensure why I'm taking these two things, because these are my independent variables. That means this two I know and this is dependent, or the quantity sold is dependent on this two. That's the reason the quantity sold is called as a dependent variable, while the price in the advertisement is called as the independent variable. Now we have to check on the labels and click on the output range box and select the where do we need the output. So where do I need the output to be shown? So I click on the output range box and then I click on wherever I need the output. Say I need the output in A11. So I select that, then check on residuals. Now the residuals will not be checked. You will have to check the residuals and click on OK. Once I click on OK, the answer will be displayed in the summary output box here. What does that say? So if you see the results here, you can see that there is a range that supplies some basic regression statistics, including the R square. So what is it doing? It's giving you the basic regression statistics. Regression statistics means we were trying to find the regression, and that's the reason that is what it is giving you. The standard error, the number of observations. Below that information, the regression tool supplies analysis of variance, which is ANOVA, including information about the degrees of freedom. This is called the degrees of freedom, sum of squares, mean square value, the F value, and the significance of F. Now, beneath the ANOVA information, the regression tool supplies the information about the regression line calculated from the data. Now, what is that calculated from the data? So it says that including the coefficient, standard error, that's the same thing that we're looking at, the standard error here. Then you have the t-stat and the probability value for the intercept, as well as the same information for the independent value. So this was for the dependent, this is for the independent value that you can see. Then, which is the number of ads. Excel also plots out some of the regression data using the simple scatter chart. So you can also add the scatter chart that you want to according to your detail that you need from this. So this is how your regression analysis works. So this is more of the statistical analysis or the financial analysis that you are planning to do when you are to the financial department using Excel. This is how your Excel helps you to do your work when it comes to working on the data analysis.